And welcome back to another episode of Let's Learn Zig. And welcome back to another episode of the Game Engine series. So what are we doing today? Well, we're going to work on our asset manager. And this is a pretty big step because I'm going to show it at the start of the code, but we're going to stop loading from the game scene. So we've been working on the game scene. Again, it just renders a monkey, a brick monkey, but we had to write our actual kind of file loader code, which we don't want. Like the game developer shouldn't have to handle that. It should just be given a nice API like load material, load shader, load mesh, things like that. And you just pass the file path and then it gives you a reference to that. And that's what we're doing today. So it's going to really clean up our code. Also introduce the kind of like a runtime context, which is where we can put things like the asset manager or assets into. Same with the IO, allocator, pretty useful for Zig because we already are passing IO and allocator basically everywhere. So it kind of bundles it all together. And yeah, so there's a lot of code in this episode. I think it's gonna be pretty common. Again, I want to keep things going, keep the series going, and make cool things. And yeah, that involves a lot of code. So I'm not gonna write everything by line by line, but again, I want to hear you guys' thoughts. Let me know how you're enjoying the series, what you think of it, and you can leave that all in the comments below. But yeah, again, long episode, so let's jump into it. Okay, so as I said, we're gonna go over the asset manager this episode, and there's a lot of code, so let's just get into it. And I'm gonna try something different where I'm gonna actually write the editor code first and then go into the runtime, because I just want to show you guys how easy, or like, I basically want to show you what the end goal is, and then we do the implementation. So the code isn't gonna run when we write the scene first, because obviously the changes aren't in runtime yet. But the goal of this is to start to show what the API change is going to be, so then it makes more sense as we're coding. So with that said, I'm just going to get into it. So there's just going to be some renaming we do this episode. We touch quite a few files. And then there's also things we get rid of, like shader, input, mesh, but then we'll need a new thing called an asset ID. Because again, we're writing our asset manager. So that's exciting down there. Also don't need speed. So now allocator is going to go. Mesh handle, we're just going to rename to mesh, and then this is going to be an asset ID. Material is also going to become an asset ID. And again, we can see this isn't going to compile or tell us this isn't working, and that's expected because we haven't written the code to actually implement it. We're also going to be introducing this kind of runtime context. So we will be changing the scene definitions once again, but now we're going to start passing a context around everywhere. And this is the big change. So we see how we're manually loading things right now. That's all going to go. I'm just going to turn something simple as this. So self.mesh, let's try context.assets.register. We'll register a mesh and give it the path. So monkey.cmesh, and then self.material, same thing. So ctx assets register, and this will do the actual loading of the file. Key.cement. And that's it. That's kind of all the loading. So you see we're not manually doing any loading. It's going to be given all down here. It's now on update, as we said. So context, we're going to start be passing everywhere. Runtime context. And then we'll need it. So let's go down here. So if what's going to happen is mesh and material are actually just IDs. So remember they're asset IDs as defined at the top. So we actually need to use that ID to get the material itself. Material equals ctx assets.get material and self.material, or else it's going to be optional because it may not be guaranteed, or else return. And same, we'll need the mesh assets get, we'll get a mesh. This will be self.mesh, or else we return early too. So now these aren't going to be self anymore. Be material mesh and all this dot bind, and again there'll be mesh. So then a couple other things is we're again passing context everywhere. So, and this is also a trick. If you don't want to do the underscore equals context, you can actually just do it right here. cp.runtime context, right? And I'll just grab that and replace allocator because it's going to contain things like allocator, IO, and then obviously our assets. So that's all the changes in game scene. There's going to be one in main, We're going to have a little bit of extra configuration now inside of application just for the asset manager. I'm going to say cooked root equals source.output, and optionally a source root is source/assets. Okay, and again, don't try compiling this or building this, it's not going to work, but that's all the changes inside of our editor. So now let's get into the actual changes. So the first thing I want to go over is just going to be adding this runtime context everywhere. So let's go in, we'll go to core, and we'll call this runtime context.zig. So what's this going to look like? cd equals import std and const asset manager. And again, we haven't written this yet, but we will be. Assets, asset manager.zig, asset manager, and then runtime context equals a struct, which is an allocator, mem allocator, and then IO. So again, this just has like things we just want around and our assets. That'll be a pointer. Okay, now that that's done, like I said, we want to start passing this around everywhere. So I'm going to go over to scene.zig. And as we did here, how we started passing context around, I'm going to do that right now. Okay, so here we are. So we have runtime context. And now we can see on startup, we pass the context. On update, we pass the context. On event, we pass the context. And on cleanup, we pass the context, right? So then it's just the same thing. So now we pass context all the way through on all these functions. And same with everything here. So context is all over. And then same at the very bottom, we have context in these definitions. So we can see this is a good way of now we shouldn't have to keep rewriting scene. If we need more parameters in anything, we can just add it to the context. And hopefully we want to make more changes to our scene definition this way, although probably will be changing soon as we serialize scenes. But now let's head over to the asset manager. So this is going to be very similar. So we'll do runtime context, import core runtime context, right? And now inside of dinit, we'll have the context, runtime context, and then we'll try instead of the allocator, again, because on cleanup, now we just made that change, it's going to take a context instead. Same when we go down to update, we'll have a context, a pointer to a runtime context, and same again with on update, and now takes a context. And then surprise, once again, runtime context. So again, I'll just speed this up. There you go, and that's all done. Okay, now that that's done, let's head over to our application and actually kind of create it and start using it. Okay, now let's import it. So we'll do runtime context and just import it from there. Nice. And now we'll come down. So we're actually going to store a context. And now this context, we'll initially set it to undefined just because the way we need to grab a handle onto the assets themselves. So this is just for ownership reasons. So then we'll define context there. Allocator equals allocator. IO equals IO. And this also means if I encourage you guys to clean up this IO and this allocator, because now you can do like self.context.io or something like that. So I encourage people to go clean that up just for the interest of time. Won't do it right now, but yeah, we might need to. So app.assets. And this isn't defined yet. So assets will be the asset manager. Or this also shouldn't be .context. It should be assets. Again, if we go here to our runtime definition, assets are the asset manager. So let's just create a to-do right here, which we'll come back to this episode. Initialize asset manager. And now let's start passing around. So we have init scene instead of IO, app.context, update scene. We'll have app.context, event callback. Again, this one will be self.context, and then dinit, we'll pass self.context there, and then self.assets. .dinit will be a function once we actually have our assets available. One other thing I want to do really quick is just clean up code as we see it. So we missed an error defer here. So if something errors, we can just deinit our window. Okay, so now before we start writing the actual asset manager itself, we need to kind of clean up our assets just a little bit. I'm going to head into shader, and there's just a couple small things that I want to clean up. So if we head up to the top in our init, we see we have the C pointers here. We actually want to kind of make this a nicer interface for us to work with, and one that's kind of cleaner, and then also calls OpenGL better. Like right now we're passing null as a length. Not ideal. So let's just try and clean up this code a little bit and help us out. Source pointer, and then length, which is a cint, int cast source dot length. Right, and then instead of source here, we'll have the pointer and then the length. Right, so that should be pretty self-explanatory. We'll do the same thing right here. Instead of doing vs, we'll do fs. And then this one will be pointer and fs length. And then we go over to our dinit. One thing we did miss was actually cleaning up the OpenGL resource, which is probably the most important thing to do here. And then we can just do self.id equals 0 to make sure it's fully cleaned up. One other thing I missed, which I think I cleaned up last time, is how this wasn't a natural OpenGL function we're calling. But we missed a little bit more. This should be an I32, and this needs to also be an int cast. So that's all for shader. And the only other one we really need to clean up a bit more, or I guess we saw there's two more. One, this is going to be a simple one. We're just renaming mesh handle to mesh, just to be consistent with what we did everywhere else. So this is just kind of code quality, code cleanup. And then material is where we actually have some true changes, because a lot of the things in here we're going to be able to just rip out and pull into our asset manager. So let's do some cleanup. So one, pointers are better when it's a bit bigger. Same with anything like this. We'll make this all public. Now instead of being load, we'll call this init from source, which now the source is going to be directly a Zimp material. We'll have a shader itself, and then just pass in the texture bindings because we'll generate them outside. And again, that's why we made it public. So now we can get rid of quite a bit of this. So all the way down until our param bindings. And that will stay the same. And then the texture, again, all the texture stuff's gone. Now it should just be texture bindings. And now try param bindings to owned slice. And we'll pass an allocator. Nice. So again, all this code kind of is going to come back, but so one kind of key note I want to say here is we're going to delete texture bindings and shader from here. So why is that? That is because if we go back, remember, we are now passing the shader and texture bindings in. That means somebody else owns it. Because we no longer own the shader and texture bindings, we don't want to deinit it, because whoever passed it in, they should be responsible for deinitting these two things. And now there is a few more changes. One, I think there's just that change wasn't actually needed. And then I think we can get rid of load texture and load shader and make relative path, I believe. Because again, a lot of that stuff will come later, and some's also been offloaded to Zimp. So that's very nice for us. So what's next? So next is this assets folder. We are going to start creating stuff for our asset manager finally. So how we're going to track this is UUIDs. So whenever you register an asset, so again, up here, we register an asset, it returns an asset ID. That asset ID is just a UUID. If you're unfamiliar, look it up. I'm not going to, this is a pure UUID implementation, so I'm just going to paste it in where it's also kind of using our type. So we can see we have mesh material texture, shader stage, and shader program. And then this is the actual code to generate a UUID, start from 0, and then just generate them at random, and then some helper functions. We'll also have asset refs, and we can infer a kind from a path. So Zimp may not load properly, but there's this new detect path. And one other thing I should call out, make sure you're using the latest Zimp. There's some updates in it which make this episode a lot easier and smaller. And there's a lot more code before, but then I tried offloading a lot to Zimp. So trying to keep this series streamlined for us as much as possible. But yeah, so UUIDs we'll be using, and that's just implementation. Code's always in the description, so go ahead, take a look. The other thing we need before we actually implement our asset manager is a source. And what does that mean by source? So source is essentially the mechanism to actually start reading the files. So that may not make sense. So right now we see, if we head over here, we have our assets, or really we have output, and then all of these. So what is our source? It's going to be the source of how we get our assets. So right now that source of how we get our assets is just all these files. So the source is a folder, and then all the data is in files, right? So what's going to come down the line is Zimp is going to implement asset packing. So what that's going to do is basically combine all these output files into a big file, and then our source will need to know how to get just one asset from that pack file. So I hope that makes sense. Right now we're just implementing like file roots, like files and directories to read from. That's going to be simple, but we'll see in the code that it's actually another kind of vtable approach. And get that in here. Okay, so let's look at this. And again, some of the series was pasting code. I want it to be reasonable sized episodes. I've written the code beforehand. I just want to be able to explain it to you guys. Smaller stuff kind of come along for the road, especially with refactoring. But okay, so what does this look like? So we have our asset errors, pretty standard. Roots, which if you remember, inside of main, that's this that we define. So where's our cooked and our source? We're going to be using this inside our application. And then asset source. So we have a vtable where we read and dinit. So reading is just going to be you open a dir and then you have your files from there, right? Very simple. And then you create a file source. So there's some validations from Zimp here, but then it's just reading a file. Like this is the important function here. All it is you read a file. You can see it's limited to the max asset bytes. We might probably want to increase this over time. That's not that big, but for now it's okay. But yeah, so reading a file, that's essentially what this does. This source is just how will we interpret our files? And that leads us to our asset manager. So create that file. And again, this is the biggest file. So it's over 400 lines of code. Gonna paste it in, and then we will go over all of it. Okay, here we go. So we see there's a lot. We see we have our UUIDs, our source, and then the different types. So first of all, what is an asset? An asset is a union on asset kind. So mesh, material, shaders, all that. So shader stage is kind of special, doesn't actually do anything, it's just an intermediate, but we still have to kind of represent it because it's a state an asset can be in. So then we have all of our assets. You can see we have dinit on them, and then our asset manager. Okay, so how are we storing these things? Well, assets are just an ID and an asset. That's it, right? Like it's a UUID pointing to an asset itself, and an asset is just one of these things. So then we have our init where we just init everything. Again, there's some extra things like that. Shader programs are a little special, but we init our file source, dinit. So here's that register. So if we come back here to our game scene, that's this function. So register probably won't load yet, but yeah, so we have our assets and we register. So it gives a type, and we, first of all, we make sure it's a proper type. It's going to be one of these. So we'll do that check first, and then just normalize the path. And then we look it up. If it's cached, we just return it, which is awesome. Otherwise, we'll generate a new ID for it. We'll load it and then put it in our storage. Okay, and then get is just going to be same. You check the type, you get the asset, and then depending on what it is, that's what you return. So all very dynamic. And then these are all just a bunch of helper functions. And then we can also load specific things, load mesh, material, texture, asset. I guess that's generalized. Create all of them. So again, these are all helper functions: create texture, load shaders, load cooked asset. So this is the generic one where it'll use zimp to load from a reader. And then yeah, so all just helper functions that we look at. Okay, so now let's hook it up. So we have a few more things we need in our application. Going back up at the top, so we'll have const asset roots, which is going to be that source. So assets source asset roots, and we'll have asset manager. Manager equals import assets asset manager dot asset manager. So now that we have that, we also need to store our assets. And then now we can kind of do our initialization. So assets equals try asset manager dot init from the files allocator IO, and then asset roots, which we need to actually pass in right here. And then error defer, don't forget that. Assets.dinit. Nice. And then we'll just pass in that extra asset roots. So that's kind of the asset config again. That's go not there. Over to main, that's these two. When we go back down, remember we already did this, but except it shouldn't be a pointer, it should be a reference. I didn't miss any code. I didn't do anything wrong. So let's build it, and not surprised, it always happens. Okay, so missing assets. Let's go back to application. So assets should be undefined, or what's the problem here? Okay, so actually what I did wrong, assets shouldn't be there. So actually we don't need to store asset manager on the application itself. At least we shouldn't have to. No field name. Oh, right. So actually we do need the assets there. And again, this is just like a weird ownership thing. Happy if anyone has a better approach to it, but we basically have application take ownership. Hopefully that doesn't seg faults. Let's see. Different problem now. So game scene. Oh, right. So now the actual, another advantage of this whole asset manager is the asset manager handles DNAing all our assets. So now again, that's another thing the game scene doesn't own anymore. I think I just had a typo there. Init scene. I think I did this a couple places. Okay, we're making progress. Yeah, see, I kept doing that. So there's that one, and oh, I really did just do it everywhere. Always have errors. Okay. And slowly making progress. Okay. Oh, it's just reversed order. Okay, we're making it down. Same thing here. On startup, we no longer need an allocator. And then yeah, that DNN at the bottom went back down to assets. And there we go. Okay. So we're back at our monkey, looking around. Monkey brick. So again, nothing's changed in our actual output. But yeah, we have our asset manager now. Okay, and that was the episode. Again, hope you guys enjoyed. Hope you guys find it cool. A little bit of debugging there at the end, but I hope that shows or help you learn something with that. Like, sure, I did some cuts, but I hope you're still just seeing, you know, it's easy to make mistakes, especially with programming language like Zig. You're going to run into seg faults sometimes. You're going to run into double freeze or memory leaks, anything like that. It will happen. Again, especially with GPU programming, it's just bound to happen. So don't be afraid, just embrace it, try and debug. Let me know if you guys want to see like a full episode of like how I debug and debug, like how to use a debugger and things like that in Zig. I think that could be useful, especially if people haven't done it before. So let me know, drop a comment down if you want to see how to debug in Zig. But yeah, I think that's all I have for today. So as always, Discord links down in the description. Come say hi, come chat, or just leave a comment. Always happy chatting with you guys. yeah, have a great day.